Sorry. Hello? Nice to meet you. Okay, please, Eric, please help me. Okay, before starting my lecture, I'll show some video and then I'll do my PPT presentation. Okay? About 7 minutes, you can. Oh, no, yeah, that's it, first.
A mild climate and distinctive 4 seasons, a vast open field, and abundant rainfall. This is Jeollanam-do in the Republic of Korea. Here in this very moment, fresh and sweet changes are starting. The lead of the changes are these special agricultural products. Taste and nutrition, of course, but also safe fruit is our focus for today. This pesticide is closely related to crab shells. This pesticide includes chitinase, not harmful to crops or people. Degrading only chitin, which is the main ingredient of crab shells.
개껍질에 새우껍질에 키틴을 먹을 수 있는 미생물들은 이 병을 일으키는 곰팡이라든가 이 껍질의 알을 먹을 수 있습니다. 다시 말해서 살아있는 병원성 곰팡이나 병원성 충의 알을 먹는다는 것은 즉 죽인다는 말입니다.
Fighting back plant pathogen against pesticide-resistant germs. This is CAP. Then, how about its effectiveness?
병해 일단 진딧물이나 응애 그리고 다른 곰팡이에 특히 곰팡이에 저는 고생을 안 했어요.
딴 데 곰팡이 고생.
네, 올해 요 주변 농가들이 곰팡이 때문에 수확을 많이 떨어졌거든요. 근데 저 같은 경우에는 곰팡이 약을 일반 농가에서 쓰는 약을 한 번도 살포 안 하고 지금까지 사용을 지속을 해왔어요, 항상.
Chitin-based pesticide is the answer to protect from damages in strawberry farming. Let's take a look at the process of how chitin-degrading enzymes and chitin-degrading bacteria kill the fungi cell walls. After monitoring for 72 hours, fungus suddenly stops growing. Does it work with tubercle nematode? Nematode completely stopped moving in 24 hours. CAP has proven that output is greater than the conventional method.
왜 월수가 없냐면 가피가 뚝 까지고 잎사귀 뚝 까지고 건강한 상태가 지금 나무를 보면은 되기 때문에 절대 병충해가 올 수 없는 한 20% 증가했다고 보면 됩니다.
No damages from pesticide and an increase in crops. How about the crucial part of taste? Generally speaking, 14 bricks, it is pretty high in sugar content. Then what about the apples grown in CAP farm? The figure shows higher numbers in conventional ones than the low pesticide farming methods. Hanabong, grown only in the southern part of Korea, are high in vitamins and good at preventing colds. While regular tangerines have an average sweetness of 12 bricks, Hanabong grown under the CAP farming system have an average sweetness of 16 bricks.
나도 기분이 좋지만 드신 분들도 안전한 먹거리가 있구나, 안심하고 먹었구나, 또 사 드신 분들도 행복할 거 아닙니까?
One more surprising fact is, these fruits have a superior effect on anti-cancer. We test the apples grown on CAP, whether it has antioxidizing and anti-cancer effects. Vitamins and selenium fight against oxidation, decrease active oxygen in the body, and prevent diabetes. The research lab at Seoul National University, led by Dr. Lee Young-sun, confirms that fruits grown on CAP have preventative agents against kidney damage, which cause common diabetes complications. The fruits grown on CAP shows maximum up to double compared to red color grown on conventional farming method. So, are you ready for the feast? There is a tableful of feast harvested from CAP. Food is important because we eat them. Food lavishes our lives with taste and flavor, and it provides
My English is not good, but I slowly will talk to for my explanation. Actually, do you know him? Talk about.
And his wife.
Yeah, about 10 days ago, he visited our country to see this farm, to confirm it is true or fake. I don't know. What is pure? Okay. Actually, today I am going to present effects of gelatinase and chitinase producing microorganisms. This is GCM. This video talk to CAP. CAP microorganism and GCM microorganism is same, but I just changed the name. Okay? I made the model, so I changed the name. You know. Okay. Yeah. Okay, today, these microorganisms control disease and promote crops. First, you have to know microorganism. What is microorganism? Microorganism is too small. Most of the soil, just 1 gram. like this size. America soil, Korean soil. Even Canada, even Myanmar, almost the same. Contains about 10 power 9 microorganisms. Think about it. We cannot see it, but we can see under microscope like this. About thousands species living in soil. But they are living creatures. To survive themselves, they have to eat. Without eat, every creature dies. What they eat? Final? Plant. Okay, let me think about first the animals. There are two animals, lion and horse. He says two are animals. But this animal, lion, eat only meat. This horse eats grasses, not the meat, not the grasses. Okay, let's go down like a worm. Do you know this one? Silkworm? This one only eats this plant, Murus alba, not any other plant, only this plant lives. Diamond back morse worm only eat the Korean cabbage. What they eat, this Fusarium, this species, microorganisms, they eat banana and tomato roots. This Alcinoia, this species eat only orange peel, not any other. Phytophthora eat the pepper roots. Botulis, this species only eat the strawberry. So if you plant like a strawberry, you wanna make money. But same time you gave a food for this microorganism. So this microorganism continuously increase and increase. Think about it. You want to make money, but you gave always a specific microorganism. Give the food. What is the monocropping problem? Monocropping means we plant tomato. Next season tomato. Next season tomato. Okay, let me think about this situation. Okay, for example, you plant the tomato. Only few space invade this root. For what? To take a nutrient, to eat. And then this species, only few species increase. Next year, already increased species, in here. So scientists ask to farmer, please rotate. Do not plant the animal tomato. Please plant the maybe pepper or onion or like the sweet melon. But most of farmers in Korea, they plant tomato and next season tomato, next season tomato. So continuous increase. But this is too small. So farmer cannot see it. I think you cannot see it. But I can see it or not. Even I cannot see it, but I can see under just microscope. Okay, next year, continuously increase. This increased, so many species can attack the root and then starting die. So farmer know that. Oh, I have to spray what? What?
Fungicide.
Fungicide. Normally fungicide and pesticide. But problem is continuous spraying of chemicals like fungicide and pesticide increase strong resistance to the pesticide and pest and the fungal, and destroy environment that even affect our health. So most of world scientists worrying about this situation. So they wanna try to another way. So they discovered the microorganisms. Some microorganisms are well known not only to inhibit or kill plant pathogens and pests, but also to promote crop growth and yield. That's very good. So, there are thousands of papers using microbial agent. Oh, I success. You know the compared control. Oh, if we treat, this microorganism, the plant health is good. We control disease. If you find from the Google, you can find it easily. Thousands of paper like this. So based on this result, company produce many kinds of microbial products to sell farmer. Farmer bought it, and then they sprayed this one to the field. But most farmers do not satisfied with this microbial agent. Why? Most result, come out from, the laboratory. Environment is totally different. This is, controlled, the environment. Temperature, humidity, like a nutrient, is perfect. But outside, it's totally different. Raining, cold, drought. Also, normally their data just grow 1 month. But our case, grow 5 months, 10 months. It's totally different. Another difference is, this is very important thing. If they have one bottle, they can use the small area. They can use the one bottle. But farmer cannot use that. So they have to dilute and then spray. Dilution is a very big problem right now. So, do you drink beer? You don't? Who drink beer? Okay, how many beers do you drink per time? 3. Okay, for example, you have 1 beer. If you drink 1 beer, maybe it's good. But now you have 500 bottles. But you have only 1 beer. Oh, how can I do? What can I do? So, 1 beer dilute with water, like these tons of water, and then give them. Scientifically, this is a very diluted beer. But drinking person think, oh, this is not beer, this is just water. Okay, let me think about that. What is the problem? Right now, worldwide, America, German, Japanese, Korea, they bought one bottle and then they mix it. They dilute with the water and then they spray. Okay, let me think about how many population of microorganisms living in like a 0.9 acre, maybe 0.33 hectare. Okay, let me think about that. First, 1 gram contains 10 power 9 population. So first, we have to get soil weight. Okay. 0.33 hectare means 3,300 square meters. Multiply about 20 centimeter depth. We can calculate this weight. So, we'll get 800 to 25 tons. If we change this ton to kilogram and then change to grams, we'll get 8.25 multiplied 10 power 8 grams. 1 gram contains 10 power 9. Multiply this soil gram. So we will get 8.25 multiplied 10 power 17 microorganisms living in 0.33 hectare, like a 0.9 acre. It means huge microorganisms living in soil. So, if I connect this microorganism tail to tail, we can go moon and then back, moon, back, 5,000 times. Do you understand? But this is too small, you cannot see. So we don't know what is the microorganism, what is the best. We just think about, oh, this is soil. Huge microorganism living in soil. So now, generally, farmer bought one bottle, then dilute it. But this one bottle, maybe 1 liter, contains about 10 microorganisms living there. It is good microorganism. Good. Very good. If I test in the laboratory, it is very perfect microorganism. So you bought it, and then dilute it. Same, 10 power in this bottle, in this container. 10 power, 10. If you spray this one to the 0.33 hectare, 33 hectare contain already 5,000 times the moon, large tree. 8 point multiply 10 power 17 divided by, like a perfect microorganism. Ratio is indigenous bacteria already contain soil, 8,250,000 microorganisms to just one. You understand this meaning? So soil think, okay, farmer think, oh, I gave the microorganism. But soil think, oh, it's not organism, it's water. You understand? You should understand. This is a very important thing. If it's success with the microorganism, have to think about this ratio. So, this is fungus. Fungus impact the cucumber. Why? To take a nutrient. Easy water to eat, to survive. So if you magnify, using microscope, see that like this. This cluster we can say cell wall. Cell wall is very, very hard material. Same as like a crab cell. The crab cell's main component is chitin. Chitin is very, very strong material in nature. Why they have this chitin material outside? For what? To protect themselves from the environment. This is the egg. From this egg came from the hatched, this worm. So these worms, skin, like the cell, also consists of chitin. What is this? Crab? See that? My computer is very clear. Anyhow, okay, that's okay. This is crab. What is this? Shrimp. What is? That's all chitin method. Okay. When you buy this chitin, this is crab shells or the lobster, and then if you dig out the soil and then put this one into your soil, some microorganism starting to degrade. For what? For eating. Some microorganism can eat this one. This is a chitin material. So some microorganism release chitinase enzyme and then break down this part and this part. This is too big, so they have to cut down to eat. Okay, think about it. If some microorganism, several microorganisms, I don't know exactly, but microorganism cut down, break down this one, they can break down this one. Same material chitin. Same material chitin. So breakdown means killing. But most country, I think you also use this microorganism. But why it doesn't work? You gave us just one bottle. Oh no, you have to at least 1,000 bottles to control this disease. Right? What is the problem? If you use 1,000 bottles, what is the problem? This one. What is this? Money? It looks like a rich lady. You can afford.
I'm farmer.
But anyhow, so if you spray 1,000 bottles, you can control this one. But anyhow. Okay, this is the worms hatched from the the egg. Skin of worms and egg mass is composed of proteins such as the collagen and gelatin. Some microorganisms, this is skin of worms and egg mass of the nematode are the gelatin material. So some microorganisms also degrade the collagen and gelatin. This microorganism also break down this collagen and gelatin. That means killing. Also, you need 1,000 bottles, not one bottle. So, about 20 years ago, I nearly tried to find, the GCM microorganism, gelatinase producing microorganism and chitinase producing microorganism, to control the GCM pest. So, I made some media, including chitin. I made the media, including the gelatin, and then I took the soil from actually the seashore, because there's some crabs. Maybe they came out and died naturally. I don't know where is the crab shell, but I did many sites, and then take them to my lab, and then I sprayed on this media. Some microorganisms show me the black jones. That means this white color is crab shell powder. They eat and then show black color because the background is black. And then I found many kinds of chitinase producing bacteria. And then I keep this one in my lab, the refrigerator. And then I started to find another gelatinase producing bacteria. So I made the gelatin media. And then this chitinase producing media I tested here. So they consume this gelatin. So these bacteria release chitinase and gelatinase. One bacteria release chitinase and gelatinase. So I tested chitinase gelatinase bacteria, that's the name is GCM, strongly inhibit growth of Phytophthora capsule. This is a famous pathogen in the most of plants. So based on 16 sRNA gene sequence, this bacteria was identified, Rhizobacter antibioticus. Anyhow, this scientific name. So these bacteria release also some, antibiotics naturally. Also, if I treated this antibiotics, this is control. If I treat antibiotics, they break down the hyphae cell walls. Also, break down eggs. You saw this one, but it's not working anyhow. That's okay. You already showed in the video. You see. Also, If I treat this microorganism, they break down, they kill these worms. Also, they promote plant growth, releasing oxygen and gibberellic acid. How to make a thousand bottle? You can buy the thousand bottle. So I'll show you this one. How to make a thousand bottles. So you have to have this cultivating container like 1,000 liter, 250 gallons, and then you have to buy this heater from I think internet. Maybe you can buy in the market in your. Also air pump, air generative pump. Maybe this is about $20 something. I don't know exactly here. In Korea maybe $30 something. You have a fertilizer in your pot, 20 maybe, something like that, right? You have this kind of fertilizer in your home. Also, you have a sugar, right? Okay. Problem is you don't have this one and this one and this one. Okay, this is the chitin material, chitin powder. This is a chitinase protein GCM microorganism. This is concentrated micronutrient. Okay, I'll show you. This chitin gelatin powder with micronutrient and GCM are added into cultivating container. These are cultivated for 3 days with air supply at 30 degrees. So this heater needs to control temperature. Then concentrated micronutrients, this one, after 3 days later, this one, fertilizer and sugar add. And then grow 3 more days. In that case, you can get 1,000 pot easily after 6 days later. And then you can spray this one to the plant root zone or plant, the leaves, depending on plant situation. Now, worldwide, they use this fermenter to get 1,000 bottles. They use this bottle, this container, this fermenter. Who can buy this fermenter? So you can buy this one, right? You don't need like this expensive. For one time fermenting, company spend $1,000. Even though you have this one, you have to spend the $10,000. Farmers cannot. So this one you can spend. You can afford it. Is mass capture of GCM possible in open environment? Yes. Chitin and gelatin are used as a carbon source. GCM are easily selected in open environment with little contamination. So now, in Korea, farmers grow this microorganism in the field side. Farmer. Mass culture of GCM by Agricultural Technology Center. This is the government side. Mass culture of GCM by Agricultural Cooperative, like 30,000. And then they distribute using like this machine, like a gas station machine. Yeah, in Korea is a very good country, I think more than Hawaii. You don't think so? Okay. Like this. Yeah, some companies sell, like a government side, they give free, like a subsidy, subsidy. So what is microorganism? Okay, we gave fertilizer, sugar, and some the chitin gelatin, and with the microorganism starting to eat this material. That's the media, we say, and then they have to change this. After eating, they have to release. Every creature, eating and release, we can say this is a metabolite. This is a metabolite. So they change into antibiotics, enzymes, glycinase, gelatinase, protease, phosphatase, and the phytohormones, IAA, auxin, and gibberellic acid, amino sugar, hexane, chitin. Many kinds of metabolite is produced. But you don't know much about it. Even Nobel Prize men don't know what is exact. Roughly, scientists roughly know. So if you have 1,000 liter, okay, if you grow or if you get from the market, I don't know. If you get the 1,000 liter of this GCM. In Korea case, you supply this 800 liter to the root job. For example, in Korea case, 200 liter left, and then mix with water, about 5 times dilute water, and then here you can use the sulfur, like Dr. Jo Young-sang, Jo Young-sang sulfur, or surfactant, plant extract, neem oil, even pesticide and fungicide. You can reduce, later I'll tell you the fungicide and pesticide. Okay, this is the pesticide pre-pumps. GCM culture was sprayed at rate of 2,000 liters. He grew themselves in the palm per 1 hectare, means the 2.5 acre, every 10 days. He grew and spray. That time, he used plant extract, sulfur solution, or surfactant. After mixing, he spray with the microbial. See that? No pesticide and no fungicide. This is okay. See that? Our dating, system is writing system is different. This is 2013. This middle is the month, June 19th. Okay. And then after harvesting green onion, they planted the carrots. So he produced carrots. Next year, 2014, again he planted the green onion. See, greenhouse and outside. GCM increased the yield by about at least 15% without pesticide. But scientists say, most scientists say, without pesticide, yield is decreasing, quality is decreasing, but it is opposite. He grew the zucchini without the pesticide. Actually, from Germany, the vice president came to me. What is this? Actually, to buy my microorganism. So I'm going to be soon, famous and rich man. It's German, anyhow. He asked me, without pesticide, his eye plant is very strong and healthy. He was surprised. But anyhow, this is the pepper. I think the Hawaiian don't like this pepper. This is very spicy. Mm-hmm. But Korean and Mexican really like spice. Yeah. 2 days ago, August 5th, I took this picture. The Korean lady farmer, he grew using this microorganism without pesticide. Another lady growing, the asparagus. See that? This is a cash crop in Korea. I think here also cash crop, right? So I am strongly suggest you to make some this cheap like a greenhouse to avoid the heavy labor. In this case, the productivity is really going high. I don't know. So I'm strongly want to suggest to you to make some just simple greenhouse, just to avoid the strong the heavy labor. Okay, anyhow. It's a Korean league. See there? January, June, November, next year. So 7 years, actually his case, 7 years, he didn't use the pesticide and fungicide. But productivity is more than. Generally, Korean farmers have a harvest leaks 4 times per year. But his case, he didn't use any pesticide. 8 times, double. Also, organic the material, organically produced leak is much expensive.
Is he continuing to apply every year?
Yes, every. So he have to use every 10 days.
10 days. Okay.
Every 10 days.
Thank you.
Did the fertilizers change on any of these?
Actually, during growing micro, I ask you about 3 to 6 kilogram of fertilizer. But during microorganism growing. So if you follow like this, it's okay. Yeah, he grow like this in his farm. 250 gallon, 250 gallon, 250 gallon, and then spray here and here and here. So some farmer came to me. Do you know exactly this farmer spray the pesticide or not? I don't know. They say I didn't spray pesticide, so I believe it. But this farmer supply vegetable to school for students' meal. Our school, administration restricts the pesticide residue. So they send this one to check the pesticide residue. So I believe about 99% they didn't use any pesticide, any fungicide.
Doctor, is the sulfur considered a benign? It's used for pesticide purposes in a way, or is it a nutrient? The sulfur, because they're adding.
Sulfur is a control to some disease. Because I'll tell you, this microorganism is not perfect, so I have to use the sulfur to control some disease. So my product is not like it's Jesus,
I was just curious as to the purpose of that particular.
Anyhow.
That's allowed in organic.
Yes, I'm not saying it makes it.
So this is what's that? The bell pepper. Bell pepper. You don't grow this rice in Korea. Before rice, before transplant rice, we planted this plant as the green manure, and then turn over, and then spray, the mud spray. This smell is perfect to erase the weeds. It's really perfect in rice field. And then agricultural company, they grow this one. And then they spray for farmers. Farmer, pay some. And then they do that. Our farmer is too old sometimes like that. So just pay and then they spray. About 3 times for whole season for rice case. So depending on plant to plant, spraying, the interval is different. So no weed because of snail. Snail is nearly more than, I think, 10 times than weed size. Oh, it's success. So many times, the YTN, like the news channel came to me to report this result to our country. So I'm going to be famous, I think. Do you believe me? Okay. Okay, yeah, just joke. Yeah, it's what is that? Yeah. Yeah, blueberry. Yeah, blueberry. No pesticide, no fungicide. So some farmer made a blend, GCM blend, to get more money, more money. This farmer, this farmer, this farmer, okay, please see the color. This color is, I don't like this color, like the disease color. Okay, anyhow, but see that this one. Okay, image. Oh, this is real yellow. Not this one because of this Okay, see that. Since 2006, he has not used pesticide. He always follow my method. 2009, 10, 14, 15, 15, 16, 16, 17, 17, 18, 18, 19. So Dr. Bob asked me, okay, actually, I heard that around 25, farmers are going to, visit our country. So he asked me to show this part. But that time, it's not yellow color. Because the next January going to be like this yellow. But anyhow, if you come to Korea, I'll show you. Some like these palms. Yeah. Okay, I am trying to say, even in Korea, most farmers are hesitating to start organic farm because they are worrying about the disease and pest. So now I'm strongly asked, reduce pesticide, but increase yield. In this case, okay, I'll tell you, okay, chemical pesticide is very rapid effects, but this pesticide gave up strong, resistance to disease and fungus and pest. That's a big problem. GCM has a slow effect, but no resistance. Low resistance. Also, GCM has a plant promoting effect. Okay, just mix it. You do not need 2 times spray. Just mix it and spray. This is a mixed spray. This is a just spray pesticide. Please help me to show this situation in Korea. No. Yeah, that's.
안녕하십니까. 저는 광주광역시에 시설원회를 하고 있는 이종희입니다. 제가 지금 농사 지은 지는 10년, 11년째가 지금 들어가고 있고요. 지금 제가 농사를 3,200평을 짓고 있는데, 미생물 관행농법은 한 2,800평, 그리고 미생물 활용을 젤라틴, 키틴 분해 미생물 활용을 한 농법은 400평을 지금 실험군으로 해서 재배를 하고 있습니다. 네, 제가 지금 관행농법이 아닌 미생물 젤라틴, 키틴 분해 미생물을 활용하고 있는데, 이 밭 같은 경우에는 수확량 같은 경우는 약 한 일반 관행농법이다 약 2.5배 정도, 2.5배에서 3배 정도를 지금 예상을 하고 있거든요. 근데 개체수가 지금 한 그루당 150개에서 170개를 지금 보고 있어요. 선충 피해도 지금 없고, 송체 피해도 없고요. 흰가루 같은 것은 아직은 보이지도 않고 있습니다. 농약을 지금 안 한 지 약 한 2달이 조금 넘었거든요. 네. 그래도 아주 양호한 상태죠. 지금 이 밭은 제가 재배하고 있는 미생물을 사용하지 않는 대조구 밭입니다. 그래서도 여기에서는 이게 농약에 일주일에 한 번씩, 7일에 한 번씩 이제 들어갔던 농약을 치면서 했던 관행농법이에요. 그런데 여기도 싱싱함 같은 경우, 싱싱함이 지금 없고 쭈글쭈글한 상태고요. 그리고 이파리가 더 노화가 너무 심하고요. 그리고 흰가루도 있고요. 지금 보시면은 지금 낙엽 현상이 이루어져가지고,
요마진 크면은 여우야 이게 다 골고 새까마이 하고 이게 몸띠가 거칠거칠하다고. 근데 지금은 그것이 아니고 이제 또 지금 오후다 해서 그렇지, 햇볕을 받아가 감수 작용해야 그렇지. 아침에 되면 여기 반들반들해 참기름 또 우찌 싹 발라놓은 부스가 발라놓은 면 반닥반닥 한다고. 그 보들어봐서 키에서 갈까 싶어서 조심스레 따야 될 정도로 그만큼 이게 물건이 좋아요. 살충제, 살균제를 안 친 자가 지금 한 달 넘었거든. 내가 사다 놓고 지금 안 치고 있는 거라. 그럼 뭐 그전에는 내가 살 일이 흰가루, 막 호박이거는 원래 죽기는 호박이는 그 흰가루가 땅에서 오는가 봐. 그렇게 해서. 그만 여 밀가루미를 막 몸띠 자체도 그렇고 여 잎에도 막 앞뒤 미네. 밀가루미를 툭 둘렀지. 그러면 하우스 들으면 문내가 나. 그 흰가루 냄새가. 근데 지금은 막 거꾸로고 몸띠고 하나도 없어. 그 약 안 친 자가 지금 사다 놓고도 안 친 자가 한 달 넘었고. 그래 이제 파리가 이 하우스 안에 이거.
네, 건강에 대한 관심이 높아지면서 요즘 농사에 농약 대신 미생물 제제를 쓰는 농민이 늘고 있습니다. 갖가지 미생물 제제는 효과가 약했던 초기와 달리 친환경 농업의 희망이 되고 있습니다. 김범한 기자가 보도합니다.
미생물 제제를 쓰는데도 병충해 걱정이 없습니다.
예전에 했던 타 미생물 농법하고는 지금 전혀 결과가 상이하게 나왔기 때문에 저도 사실은 깜짝 놀랐습니다. 화방에 전혀 문제가 없이 또 딸기도 뭐 저장성이나 당도가 떨어지지 않고.
다른 농민은 올해 딸기 소득이 지난해에 비해 배 가까이 늘어날 전망입니다.
저 같은 경우에는 시로참이 아니고 이거 하나 자체에서도 벌써 한 30개 이상이 달리니까 이미 수확 자체가 그만큼 많이 했기 때문에 그만큼 좋은 겁니다, 이게. 지금 벌써 우리는 수확이 한 방이 차 있는데 한 포기에 지금 평균 이게 한 3개씩 이렇게 나옵니다, 벌써. 3개, 4개씩. 이게 이 정도가 아니고 계속 지금 땄는 게 내가 이걸 2컵으로 담는데 지금 보통 담는 게 4호가 나옵니다, 딸이. 나오는 게 하루 평균 100박스 이상 나가요. 내 총 모종을 심었는 게 24,000개입니다. 모종 숫자가. 24,000개에서 하루에 100박스 이상 나간다면 상상을 못하고 전부 거짓이라고 생각할 겁니다. 전부 다.
제가 이 도마도는 작년에 제가 이 딸기 심고 후작으로 3월 3일날 정신했는데 원래 그 딸기에 GCM을 계속 쓰면서 이제 도마도 같이 여니까는 이 도마도 크는 속도라든지 가 굵기라든지 그런 게 눈에 띄게 다른 농가에 차이 나더라고요. 지금 같은 경우는 이것도 계속 10일 한 번씩 도마도에다 관주를 하고 예매 삽도도 안 하고 농약은 전혀 없는 도마도 올해 처음이기 때문에 어떤 농약 쓰는지 모르고 농약 써본 적이 없습니다. 그냥 오로지 GCM만으로 키우는데 보시다시피 이 가 크기라든지 도마도 이런 수세 같은 게 엄청나게 좋아가지고 제가 올해 그 3월, 4월, 5월 같은 경우는 도마도하고 뭐 딸기하고 같이 뭐 익어 놓으니까는 제가 정신을 못 차리고 같이 너무 빨리 크니까는. 그래서 앞으로도 지금 뭐 이제 7월 말까지 따고 이제 딸기를 뭐 준비하기 때문에 일단 7월 말까지 뭐 딸만 따고 일단 뭐 접던지 해야 되죠 지금. 보시다시피 딸기 도마도가 뭐